Okay, so here we're going to solve out another one for the geometric proof based on this here. So we have, let's try to read out here the given down. So we have Converse of Theorem 3 is the line from the center of a circle to the midpoint of a chord is perpendicular to the chord down here. So we're going to prove out that triangle OXA is congruent or equal to the triangle OXB, and therefore angle OXA is equal to angle OXB then. Okay, so let's just try to find out the answers down here. So let's go start out with the first one here. So first we're going to prove that the triangle OXA is simply equals to or congruent to the other one. So let's go on for the solving down here. So trying to remember how here for the figure to prove out these two triangles are congruent, we're going to use out the side congruent criterion by identifying the three pairs of the equal sides. Now, to do that one here, let's go start with the first one. Okay, so we have OA is simply equals to OB then. Now this one here, we can see out that both in the segment are radii in of the same circle then. Okay, now next one we have is, okay, now we can see out here, we have AX is equals to BX then. So given that here we can see that X is the midpoint and the chord of AB then. Now, moving on for that, let's try to move on to the second one then. Now, the second one here is we have here that OX is simply equals to OXY because they have the common side and by both they were being shared by the triangles then. Okay, now moving forward for that one here. Now let's go move on then. So this one we able to see out all of the three sides then here. So that conclude that the triangle OXA is simply a congruent to the triangle OXB then. Okay, now moving forward for that one, for the other one down here, is we're going to find out the next one then. Now, moving out here, we can conclude that the congruent of the angles of OXA is simply equals to the angle of OXB then. Okay, so that one proves out for the first one. Now here, we're going to prove out that OX is perpendicular to the side AB then. Now let's try to see out here then. First, to know out this one for the B, we're going to for the B down here is to prove that OX is simply perpendicular to AB. Now looking out here for the figures out again. Now let's try to add all the angles down here. Does they make out 180? So moving out here, first we're going to find out the angle of OXA. And if you can see out in the figure from OXA, we have formed that one, and next one we're going to add that one to OXB. So giving out here, that's going to give us with a 180 degrees. They have a total for that. Now, moving on for the other here is, okay, now let's try to find more about that. Now, looking out for the other parts, for this here we have, and why do we have for the 180? Because angles on the straight line A and B sums to 180 here. Now, since we have the angle of OXA X and A is simply equals to OXB from the one that we see on part A. So we're going to write it out as angles of OXA down here is like plus the angle of OXA is equals to 180 then. Now, moving for that one here, we have to look out. Then that's going to be about 2 angle of OXA and A. That's going to give us with an equal of 180. And moving for that one here, then that's going about divide both sides. That's going to have OX and A is simply 90 degrees then. Okay, now since we have the same or is they are equal to the other one, let's try to write it down then. Okay, so OXA is equals to angle of OXB, and they are both equals to 90 then. So we can prove that OX is really perpendicular to AB 10. Okay, so that one shows out for the solution.